Hello everyone, welcome back to the E mode of learning. I hope you have watched the previous video on differentiation, that is differentiation part 1, and again hoping that you give a try to the questions that were given as homework. So let us begin with the homework questions, and today we'll be learning a couple of concepts and followed by the solving of questions from your ICI module. So let us begin. So the first question that was given as homework was, if x is equal to t plus t to the power minus 1, y is equal to t minus t to the power minus 1, find the value of dy by dx. Now, if you turn the pages of the last class, you will be able to figure out that it is an example of parametric differentiation, right? Where x and y are two variables expressed in terms of a third variable, that is variable t. So, in this case, dy by dx is equal to dy by dt into 1 upon dx by dt, or just in short we can write it like this, right? Now here I need to know what is dy by dt and what is dx by dt. So x is equal to t plus t to the power minus 1. So dx by dt will be, if I differentiate t with respect to t, I get 1 plus, if I differentiate t to the power minus 1 with respect to t, what do I get? Please apply the very first formula, x to the power n. If I differentiate x to the power n, I get n into x to the power n minus 1. So here n is minus 1. X is t to the power n minus 1, right? So it becomes 1 minus 1 by t square, because t to the power minus 2 becomes 1 by t square. Similarly, if y is t minus t to the power minus 1, then dy by dt will be 1 minus 1 by minus 1 by t square. So it becomes 1 plus 1 by t square. There are similar expressions with just change in this sign, right? So dy by dt will be 1 plus 1 by t square. Dx by dt is 1 minus 1 by t square. Now taking the LCM, t square plus 1 upon t square minus 1. So final answer is t square plus 1 upon t square minus 1. Now the second question. Now let me make this question a little more interesting. If I add the condition, find the value of dy by dx for t equals to 2. In that case, dy by dx when t is equal to 2, it becomes, just substitute the value of t as 2 and I get the answer as 5 by 3. So here we have solved the first question of the homework. Second question. Second question, which was given in the end of last video. The question was, if x to the power y is equal to e to the power x minus y, find dy by dx. And you were given 4 options as well. Now please note that Here x is also a variable, y is also a variable, and it is in terms of first variable to the power second variable. If you remember, in the end of the last video, we discussed a concept called logarithmic differentiation. Where do we use logarithmic differentiation? When the function is of the form fx to the power gx, right? Here x is one of the functions and y is the another function. So we have to use logarithmic differentiation. So what am I going to do? Taking log on both sides, right? So the left hand side becomes log x to the power y is equal to log e to the power x minus y. Note that e is always there, the base is always e. So it becomes y log x is equal to, now x minus y log e to the base e is 1, right? Because the power becomes a coefficient, we are left with log e to the base e, which is nothing but 1. So hence we are going to write it as just 1. So y log x is equal to x minus y. Now next I am going to differentiate both sides with respect to x. So ddx of the left hand side function is equal to ddx of the right hand side function. So here you have to apply u into v. If y is equal to u into v, dy by dx is equal to, taking the first term as constant, differentiating the second one, plus taking the second term as constant and differentiating the first one. Similarly, I'll take the first term as constant, I'll differentiate log x. I know that if I differentiate log x with respect to x, I get 1 by x, plus taking the second term as constant, I have to differentiate y. So it will be dy by dx is equal to, first I have to differentiate x with respect to x, so 1 minus I have to differentiate y with respect to x. Clear? Now all the terms containing dy by dx on the left hand side, so the second term and the second term on the right hand side, rest all the terms on the right hand side. So dy by dx I'll take as constant log x plus 1 equal to, I'll take the LCM, right? So finally dy by dx is equal to x minus y upon 1 plus log x. Now in the options that were given, there was no mention of y. Everything was in terms of x, right? So it means I have to convert this y into x. Now how am I going to do it? Please take note in the given equation. Here every term containing y is brought to the left hand side. right? What will I do? I'll take y as common. Therefore, y is equal to x by 1 plus log x. So here, y is expressed completely in terms of x. So y is what? X by 1 plus log x upon x into 1 plus log x. I'll take the LCM, 1 plus log x into 1 plus log x minus x upon x into 1 plus log x is equal to x plus, I'll open the bracket, log x minus x into x into 1 plus log x whole square, right? X log x upon x into 1 plus log x whole square. So I'm left with the final expression, that is log x upon 1 plus log x whole square. You can pause the video and try it yourself, because unless and until you try it by yourself, you won't be able to solve it later. Fine. The next concept which we are going to learn today is higher order differentiation. It is relatively a very easy concept. Now, suppose you are given a function, say y is equal to x to the power 5. Y is equal to x to the power 5 is also an equation of a curve, right? Now, if I differentiate y with respect to x, what do I get? X to the power n. So, going by the very first formula, if I differentiate x to the power n, what do I get? N into x to the power n minus 1. This is nothing but the first order derivative. It is called first order derivative. It can be also written as y dash. If I want to differentiate it further, y double dash, or I'm differentiating this expression again, so dy of dy by dx, right? Now I have to differentiate 5 into x to the power 4. Already discussed in the last video, if there is any constant multiplied, that constant will be will appear as it is, and I have to differentiate x to the power 4. So n into x to the power n minus 1. So final answer is 20x cube. This is nothing but the second order derivative. Similarly, I can get third order derivative, where I have to differentiate this expression again. So this becomes 60x square. This is third order derivative. So this is it. Let us solve an example from the question, an example from the book. If y is equal to fx, is equal to x to the power 4 plus 5x cubed plus 2x squared plus 9. If I am to find the first order derivative, that is y dash, or I can call it f dash x also, so I have to differentiate. So what will this become? 4x cubed plus 5 into 3, 15 x square. By now you must be comfortable with these sort of differentiation. 4x plus 0, right? Second order derivative, that is y double dash or f double dash x, is equal to 4 into 3, 12 x square, 15 into 2, 30 x plus 4, right? So this is my second order derivative, and similarly I can keep on finding the higher order derivatives. Another question: if y is equal to a into e to the power mx plus b into e to the power minus mx, prove that d2y by dx2 is equal to m square y. Okay, now please note that the second order derivative y double dash can also be written as d2y by dx2. Clear? So it means the second order derivative of y with respect to x should be equal to m square y. So let us try. Y is equal to a into e to the power mx plus b into e to the power minus mx. If I find the first order derivative, that is dy by dx, constant as it is now, if I differentiate e to the power mx, what do I get? E to the power mx. Chain rule, this is not x, this is mx. So I'll have to differentiate mx again with respect to x, right? Plus, similarly, as the first expression, so a into e to the power mx, if I differentiate mx with respect to x, what do I get? M. Why? Because m is a constant and I have to differentiate x with respect to x. So as the rule says, constant will come out. If I differentiate x with respect to x, what do I get? M. Sorry, 1. So here, how do I get? This is how I get 1. So b into e to the power minus mx into minus m. So this is my dy by dx, right? I'll have to differentiate the above expression once more so that I get the second order derivative, that is d2y by dx2 or y double dash. It is equal to, now here a into m are constant, right? I'll have to differentiate e to the power mx. So e to the power mx, I can directly write now m, as we have already seen in the above line, plus b into minus m comes together. They come together because they are constant terms. I have to differentiate e to the power minus mx, so e to the power minus mx minus m. So finally this becomes am square into e to the power mx plus bm square. Minus m into minus m becomes plus m square by minus mx. Now I can take m square common out. A into e to the power mx plus b into e to the power minus mx. If you observe, this term is nothing but the expression y. Hence, d2y by dx2 is equal to m square y. You have to keep in mind in this question that A, B, and M are constants. Let us move forward to the next and the last concept of today, that is geometrical interpretation of the derivative. We have already covered this in the beginning of the chapter, which I had taken in the class, but let us do it once again. So this is the Cartesian plane. Now let us take this as any curve, that is y is equal to fx. Now, why do I find dy by dx? Dy by dx is nothing but the slope of the curve at any given point. Now, what do we mean by slope? Suppose at this point, I want to find the slope of the curve. So, here is the slope. This line is nothing but the tangent. Tangent is nothing but a straight line which just touches the curve at one point. So the slope of this tangent is the slope of this curve at this given point. What will be the slope of this curve at this point? It is nothing but the slope of the tangent at this particular point. So we see that the slope of this curve varies as the point varies. Here the slope, for example, will be 1. Here it will be somewhere near to 0. So for a single curve, the slope keeps on changing depending on the coordinates given. So in order to find the slope of any curve, we are just to find the first order derivative. Another name for slope is gradient. So gradient is equal to slope is equal to dy by dx, where y is the equation of the curve. Let us see one question. Find the gradient of the curve y is equal to 3x square minus 5x plus 4 at 1, 2. So here I have to find the slope of the curve y is equal to 3x square minus 4x plus 4 for this particular point. So slope is nothing but dy by dx, so I have to differentiate 3 into 2, 6x minus 5, right? So dy by dx for the point 1, 2. Now this is the x coordinate, this is the y coordinate. Here wherever there is x, I have to replace it by 1. Wherever there is y, I have to replace it by 2. So there is no presence of y, so let us just put or substitute the value of x as 1. So 6 into 1, 6 minus 5, 1. So the slope of the curve at 1, 2 is 1. Okay, now please refer to your ICI module. We are going to solve some questions from the exercise. Please take out page 8.19, exercise 8A. Let us try question number 2. 1 and 2 are very similar. I'll solve question number 2. You can try question number 1. So, if y is equal to 2x cubed minus 5x squared minus 3x, find the gradient of the curve at x equals to 0. So gradient is nothing but dy by dx. So 2 into 3, 6, x square minus 5 into 2x minus 3. So dy by dx at x equals to 0 is, substitute the value of x as 0. So answer is minus 3. Option B, minus 3 is the right answer. Let us try question number 3. You can always pause the video and try the questions on your own, and then you can watch the solution. The derivative of y is equal to x plus 1 and the root x plus 1. So I can always write it as x plus 1 to the power half, because root is nothing but to the power 1 by 2. So dy by dx. What is the basic formula for this? Y is equal to x to the power n. So n into x to the power n minus 1. This is not x but x plus 1. So I can always differentiate this with respect to x. Chain rule. So half into x plus 1, half minus 1 minus half, into differentiate x with respect to x1 plus 0. So 1 by 2 x plus 1 to the power half or under root. Option C. Question number 4. If fx is equal to e to the power ax squared plus bx plus c, then f dash x is. So f dash x means I have to differentiate. So e to the power anything will be e to the power that expression, but I have to again follow chain rule. So I have to differentiate x squared plus bx plus c. So it becomes the given expression into, okay, now ax squared. So a comes as a. If I differentiate x squared, I get 2x plus b as it is. If I differentiate x, I get 1 plus c, which is 0. So the final expression is e to the power x squared plus bx plus c 2ax plus b. That is option B. Question number 6. Y is equal to x into x minus 1 into x minus 2. Then find dy by dx. So I can expand it. It becomes x squared minus 3x plus 2 x cubed minus 3x squared plus 2x. Now it is easy to differentiate. So this becomes 3x squared minus 3 into 2, 6x plus 2, right? So option A. Question number 7. The gradient of the curve. Okay, the curve is given y minus xy plus 2px plus 3qy is equal to 0. So it is given that the gradient of the curve at gradient of the curve at the point 3, 2 is minus 2 by 3. I have to find 7. Here I have to differentiate the given expression in order to get dy by dx. So the given curve is given, I have to differentiate it with respect to x. This is minus 4x plus 3qy. Okay. Okay. So if I differentiate y with respect to x, I get dy by dx minus, I have to differentiate x, y. Taking the first as constant, differentiating the second, plus taking the second as constant and differentiating the first. First, that is x. If I differentiate x with respect to x, I get 1 plus 2p as constant. Differentiate x with respect to x1 plus 3q as constant. Differentiate y, I get dy by dx is equal to 0. So dy by dx minus x into dy by dx minus y plus 2p plus 3q dy by dx is equal to 0. All the terms containing dy by dx on the left hand side, and I can take it as common. Rest everything on the right hand side. So finally dy by dx is equal to y minus 2p upon 1 minus x plus 3q. In the given expression or question dy by dx 3, 2, I'll substitute the value of x as 3, y as 2. So 2 minus 2p, 1 minus 3 plus 3q. It is given to be minus 2 by 3, right? So 2 minus 2p minus 2 plus 3q is equal to minus 2 by 3. So let us solve it further. This is what I get. P minus q is equal to 1 by 3. Now, they've asked us the value of P and Q, right? Now, here we have just got one equation and two variables. If you look at option 1, P is equal to half, Q is equal to half. In that case, P minus Q becomes 0. Option B, 2, 2. If P is 2, Q is 2, P minus Q again becomes 0. In C also it becomes 0. But in option D, half minus 1 by 6, it becomes 1 by 3. So this is how I can find the value of P and Q with the help of elimination. Also, if you want to find the second expression or the equation of the second line, not line actually, equation containing P and Q, in that case, what will I do? In the given curve, I'll substitute x as 3, y as 2. So I get 2 minus 2 into 3 6 plus 2 into 3 6, p plus 10 into 6, q is equal to 0. So p plus q, you're going to get it as 4 by 6, that is 2 by 3. So one equation, second equation, but given the contingency of time, we can solve it in this way, investing less amount of time. Next, question number 10. If x xy is equal to 1, then y square plus dy by dx is equal to what? Okay, now what is the given curve? Xy is equal to 1. So I'm going to differentiate it with respect to x. Taking the first as constant, differentiating the second, plus taking the second, differentiating the first. So I get x into dy by dx is equal to minus y, taking it on the right hand side. Expression for dy by dx is minus y by x. Okay. Now, what have they asked us? Find the value of y square plus dy by dx. Y square, what is dy by dx? Minus y by x. If I take the LCM, it becomes xy square minus y. Okay, rather do it this way. Now, x into y is equal to 1. So what is y? Is equal to 1 by x. So what will be y square? 1 by x ka whole square, right? So 1 by x square minus y by x. Now LCM becomes easier. 1 minus x into y. Now x into y is equal to 1. So I substitute the value of xy as 1. 0 by x square. So it's 0. So option B. Question number 11. Find the derivative of the function x plus root x ka whole under root. So this can be rewritten as x plus x root x to the power half. So dy by dx, x to the power n into x to the power n minus 1. Chain rule. Since this is not x, this is x plus root x. So to the power minus half. नीचे जाके प्लस हाफ हो जाएगा. The dx of x is 1 plus root x. It becomes this. You can check it. Option C. Question number 13. If x square by a square minus y square by a square is equal to 1, dy by dx can be expressed as a square. I'll take the LCM. So this becomes a square. X square minus y square is equal to a square. Now I have to find dy by dx. So let us express y square as x square minus a square. Y is equal to under root of x square minus a square or x square minus a square to the power half. So dy by dx, x to the power n. So n into x to the power n minus 1 into chain rule, right? Because this is x square minus a square and not just x. So this becomes this into 2x minus 0. So the final answer is x by under root x square minus a square, which I think is option E. Question number 15 is an example of implicit expression, implicit function. You just have to find dy by dx. Rest all the questions are quite easy. Parametric 16, 17, they're all examples of parametric equations. 19, number 20. Okay, this is a good question. Let us see. The slope of the tangent to the curve y is equal to 4 minus x square. Can also be written as 4 minus x square to the power half, right? The slope of the tangent to the curve at the point where the ordinate and abscissa. Ordinate is the x coordinate, abscissa is the y coordinate. So in short, I have to find the slope of the tangent to the curve where the x coordinate is equal to the y coordinate. So slope के लिए dy by dx n into n x to the power n minus 1. Chain rule, I have to differentiate the expression 4 minus x square. Right. 1 by 2 root 4 minus x square into 0 minus x square becomes 2x. So minus x by under root 4 minus x square. Now, what is this? Equal to y? Yes or no? So minus x by y. Now, dy by dx when x is equal to y, it is equal to minus 1, right? Question number 21 is similar. 22, again implicit function. You have to find dy by dx and substitute x as 0, y as 0. 23, u by v method. 24, there is a correction in option B. Denominator mein it is x into y log x, not x log x, it is y log x. Excuse me. So let us try question number 24. X to the power y into y to the power x is equal to m. So the beginning of this video we solved a question involving x to the power y. So here we have to take log because it is of the form fx to the power gx. So if I take log on both sides, it becomes this. Please note that log a into b is nothing but log a plus log b. So this becomes x to the power y plus log y to the power x equals to log m. Power becomes the coefficient in log. Next, I have to differentiate with respect to x. So, the first expression, it is of the form u into v. First is constant, differentiating the second expression is constant and differentiating the first plus x log y. X into I have to differentiate log y plus taking the second expression as constant, I have to differentiate the first. Okay, this is 0. Why? Because m is a constant. Log m is also a constant. Hence, differentiation of log m is 0. Y by x plus log x into dy by dx plus x into ddx of log y. ddx of log x is 1 by x, so it becomes 1 by y. Chain rule into dy by dx plus log y into 1. All the terms containing dy by dx on the left hand side. Second expression and the third. Rest everything on the right hand side. Therefore, dy by dx can be written as minus log y plus y by x upon log x plus x by y. You can take the LCM, x log y plus y upon y log x plus x. So it becomes minus y x log y plus y upon x into y log x plus x. Question 29. Y is equal to root 2x plus 3 to the power 2x. Okay, this is root 2 into root x, right? So dy by dx, constant will be constant, x to the power half. This is x to the power half, right? So half into x to the power minus half, half minus 1, that is minus half, plus, if I differentiate, okay, this is of the form a to the power x. So if I differentiate a to the power x, what do I get? A to the power x into log a. So a to the power x into log a, that is 3. Now this is 2x, not x. So I have to again differentiate 2x following chain rule. Sorry, this is root 2. Constant remains as constant, right? So cancel 1 by root 2. X to the power minus half matlab minus, sorry, 1 by root x plus 3 to the power 2x into log 3. If I differentiate 2x, I get 2. So the final expression 1 by 2 root x plus 3 to the power 2x log 3 into 2. This is option A. Rest all the questions are very similar. Next, let us try 36. If x is equal to x square minus 6x plus 8, what is f dash 5 minus f dash 8? सबसे पहले find f dash x. First order different derivative, that is 2x minus 6, right? So f dash 5, instead of x I'll have to replace x by 5, f dash 8. So f dash 5 minus f dash 8, that is 4 minus 10, that is minus 6, right? Okay, here the option is not given in the direct form. If you observe, you have to find f dash 2, that is 2 into 2 minus 6, 4 minus 6, that is minus 2. So what do I multiply with minus 2 in order to get minus 6? 3, right? So option B. Next, let us try question number 5. Okay, now 5 may look a bit, not a bit, but quite tough. But please note that the value of e to the power x is 1 by x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. So this expression on the right hand side is nothing but e to the power x, right? So if I differentiate dy by dx, e to the power x remains as e to the power x only. What is e to the power x? It is nothing but again y. So dy by dx is again is equal to y. So can I say dy by dx minus y is equal to 0? That is option C. So here you have to remember that if you ever see an expression of the form this, it is nothing but e to the power x. Question number 44. The differential coefficients of x square plus 1 upon x. Differential coefficient is nothing but the derivative. So u by v, if you apply v du by dx minus u dv by dx upon v square. V into differentiate x square plus 1, I get 2x plus 0 minus second expression, differentiate the denominator, I get 1 upon x square. You may take time and solve, right? So x square minus 1 upon x square, that is 1 minus 1 by x square. That is option B. Question number 46. Y is equal to root x to the power root x to the power root x and infinity. You have to find dy by dx. Okay, now y is equal to root x. Now I group the expression from here to here, right? So again, this is nothing but y. So y is equal to x to the power y by 2. I have to apply logarithmic differentiation because on the right hand side it is x to the power y, right? So I have to take log on both the sides. So log y is equal to y by 2 into log x. If I differentiate log y, what do I get? If I differentiate log x, I get 1 by x. So 1 by y. This is not x, this is y. So dy by dx, chain rule. U into v. Now let us take half outside only. So y into log x. So first expression differentiating the second plus second expression differentiating the first. All the dy by dx term on the left hand side. So this becomes log x by 2 to dy by dx y by 2x. So dy by dx into 1 by y minus log x by 2 is equal to y by 2x. I'll take the LCM. So 2y, 2 minus y log x. So y by 2x cancellation. Finally, dy by dx is equal to y square x into 2 minus y log x. That is option B. Right? So we are trying to solve the variety of questions given in your book rather than just solving the redundant ones. Please try and solve the remaining questions. They are very similar to the ones we are doing in this video. And the last question if fx is equal to 4 minus 2x upon 2 plus 3x plus 3x square. Okay, now fx is this, then the values of x, I have to find the value of x for which f dash x is 0. So the first order derivative. So f dash x, I have to find the first order derivative. So this is again u by v. So v into differentiating the first 0 minus 2x को differentiate करेंगे मिलेगा minus 2 minus first term differentiating the denominator 0 plus 3 plus 3 into 6x. You can take your time, you can pause the video and solve. So this becomes minus 4 minus 6x minus 6x square minus 12 plus 24x minus 6x minus 12x square upon, okay, this will be whole square, I'm sorry, 2 plus 3x plus 3x square whole square. So finally 4 minus 2 minus 16 minus 24x plus 6x square upon 2 plus 3x plus 3x square का whole square. Now x, f dash x is given to be 0. I have to find for what values of x this whole expression will be 0. If I cross multiply, I get minus 16 plus, sorry, minus 16 minus 24x plus 6x square is equal to 0. I divided by 2 and arranging 3x square minus 12x minus 8 is equal to 0. So this is a quadratic expression. If you remember, x is equal to minus b plus minus b square minus 4ac divided by 2a. So here the value of x will be minus of minus 12, 12, 144 minus 4 into 3 into minus 8. So this becomes plus upon 2a, that is this 6. 12 plus minus 144 plus 96, which becomes 240 upon 6. So 12 plus minus 240 can be written as 16 into 15, that is 4 under root 15. You can take your time for calculation. So this becomes 12 by 6 plus minus 4 root 15 upon 6. So 2 plus minus 2 by 3 under root 15. Okay, so going by the options. So 2 plus minus 2. If 3 goes inside root, it becomes 9. So 15 by 9 becomes 5 by 3. So 2 plus minus 2 under root 5 by 3. If I take 2 common, 1 plus minus root 5 by 3. So option A is the correct answer. So in this video we have tried solving the variety of questions given in this chapter. So I hope the remaining questions will be solved by you, and in the next video, that will be the last on differentiation, that is differentiation part 3. Here we are going to discuss on the applications of differential calculus.